Good morning. Bill here. Um, Let me give you a little indication of where we're going in this section. Let's go to our friend google.com, and there is our Google. And I don't know, let's search on cat. And there's some very few cute pictures of a cat here. Um, Here's the thing that I want you to note that when we come right up here, I'm trying to give you some motivation for this chapter. It's telling me that it found about 4 billion documents. Also, remarkably, it's telling me it found that in 0.89 seconds. I'm not quite sure. I'm not sure I believe either one of those numbers. But we can scroll down the page here. Um, and there's all sorts of stuff here, and it goes on and on and on. And I'm not showing you the whole screen. But 4 billion documents is quite a few documents to be presented with. And the problem that we want to look at in this section is what do we do with all those documents? Or is there any way that we can present those 4 billion documents in a more meaningful way? Um, and there's a lot of interesting research that's going on in that area, and we're going to get to that. But so that's the motivation for the talk here right now. But what I want to talk about first, I indicated to you in some previous lectures that this class, we're taking a class here in information retrieval, and there are some certain similarities here to information retrieval and something called data mining. Um, Mining, ING. Haven't had enough coffee this morning. The other thing is machine learning. And what I want to talk about here for a few minutes there's a vocabulary that dominates all of these disciplines. And I think it might be good for us to talk about this vocabulary a little bit. Um, Before we get into the vocabulary, I want to tell you a story. Um, I've been teaching computer science for a long time now. Um, and as much as I really love my job, and I do, I really don't like grading. It's tedious. Um, I don't get a whole lot out of it. And then when you're done grading, you usually have a bunch of people that want to argue with you about grades. And there are a couple of things that I've learned over teaching computer science over the years, and I've been teaching it for over 30 years. Um, and the thing is that I can say the following: I can spot an A student. Again, 30 years of experience. I've got a long list of student names, and here's Joe Smith, and here's Sue Jones, and here's a whole list of other people. I've got a database of this, and I could just come over here and I could say yes, yes, no, yes. And the thing is here's what's happened. I've been doing this for a long time, and I actually know what it is to look for when I want to know if someone is an A student or not. So one of the things I want to look at is handedness. And by handedness, I mean, are they a lefty or are they a righty? So over here, I have a thing called handedness. Handedness. And LR, and it goes on like that. Um, and then the thing is I want to know, do they wear eyeglasses? And that could be yes or no. So I'm going to come over here and I'm going to write I, and yes, yes, no, yes. And it goes down like that. And maybe height. And when I say height, I'm going to keep these discrete values right now. So I'm going to say you're either tall, medium, or short. So I have height over here. And some people are tall, and some people are short, and some people are medium. And I've got 30 years of data over here. Okay, so there are a couple of things that I am doing here. First of all, there is a hypothesis here. I'm not sure that it's true, but there is a hypothesis. And somehow the hypothesis is that grade performance is a function of handedness, height, and eyeglasses. So, in other words, what's going on here is I think that I can have that there is somehow a function, and inside of this function, I can specify three variables. One of them is the handedness, and there's height, and there's eyeglasses. So remember, this is either yes, no, and height is either tall, medium, or short, and handedness is either left or right. So in this particular example, I am assuming that the three input variables all assume discrete values. And this particular function over here is a Boolean function. It either outputs true or false, meaning they get an A or they don't get an A. It outputs either true or false. Now, it may be the case that my hypothesis is incorrect, and maybe I should be including things in here like the number of hours that you study per week, how much mathematical background you have. There could be a whole lot of things, but this is the assumption that I'm making in here. And the idea is that I have over here, I have some data. And what I want to do with this data, this is what is referred to as labeled data. Labeled data. And the reason why it's labeled is because I actually have a column with the outcome that I am trying to predict. Okay? So what I am doing over here is I have all of this sample data that I've accumulated for 30 years. And let's remember what the goal is. The goal is that I don't want to grade papers anymore. In other words, the goal here, this is very important, the goal is to be predictive. In other words, I want some student that's coming in the door, and I'll just be able to look at them and decide whether I'm giving them an A or not. Okay? So what I am trying to do here is I am attempting to predict with labeled historical data. And remember, labeled means I have the value. I have historical data with outcome I'm trying to predict. Okay, this is very important. So, how do I go about and do this? Well, there are lots of ways to do it, and it is not my intent to talk about how we're going to do that here. But just to give you some ideas, I might use a neural network. Maybe you know what that is. Maybe you don't know what that is. That's okay. Maybe I might use a Bayesian classifier. That's another thing that I could do here. Maybe I might use a decision tree. And again, these may be terms that you're not aware of. I do hope in this class we're going to talk about this one, and we're also going to talk about this one. But the idea is I build a model. And here's the model, whatever it is. And what happens is I have this labeled training data. So I have this training data. And that training data is just the stuff, is just this table right over here. And what happens is I build a model and I come along and first I take this piece of data right here. I take Joe Smith with, he's left-handed, does wear eyeglasses, and he's tall. And Joe Smith was an A student. Now what happens is I come over here and I feed that data in here, and this model spits something out. Now if it spits out true, yes, he's an A student, I'm really happy. But if he doesn't spit out a true, if it spits out a false, then what I've got to do in here is I've got to come in here and I've got to adjust the model somehow. Okay? Then what I do is I go to the next example, and the next example here is going to be Sue Jones. And let's see, Sue Jones is right-handed, wears eyeglasses, and is tall, also an A student. So I put all of that data in here, and I take a look at what comes out. Now, if it comes out true that she's an A student, I'm really happy. And if it comes out that she's not an A student, I've got to come in here and I have to do some adjustment to the way the model is built. Now, what my eventual goal is here is that I'll be able to run through all of the data in my database and get the correct outputs. And once that occurs, and I should say if that occurs because it may not occur, but let's assume it does occur, at that point we would say that the model is trained. And at that point we are now ready to go do predictive work. Okay? Now what I've gone through here, the process here, okay, first of all, I want you to know we had labeled historical data. And then what we did is we built a model. And then 3, we checked the model against the labeled data. Now, this whole process right here has a name. And the name for this is called supervised learning. And the whole thing that makes it supervised learning is the idea that we had labeled historical data. Now, over here it says check the model against labeled data, and I'm going to say over here 4, I'm going to say adjust accordingly. If we do number 4, that is called with feedback. So that the entire process that I just described to you right here, right now, is called supervised learning with feedback. Okay? In other words, what happened is we put a labeled data into the model, and if the model agreed with our observed historical data, we don't do anything. If, on the other hand, it doesn't agree with it, we make adjustments to the model. The adjustments to the model that we're making, that's what's called with feedback. The idea, supervised learning, means that we had historical data. Now, why are we talking about this? Well, quite simply, what we're going to be doing in this particular section is we're going to be talking about something called unsupervised learning. And so the question is what is unsupervised learning? And I think it's probably good to contrast it with what is supervised learning. So unsupervised learning means there's no historical data. And there's also very few assumptions. About the data. Now, what does this mean? Well, again, let's consider an example. Now, I want to assume a different type of data here, and you'll see where I'm getting at in a second. So I'm going to draw an XY plane over here, and I want you to assume that I've done some sort of experiment. And the experiment has a bunch of XY data in it. Okay, and what I mean is, I have a file, and there's lots of points in it, XY points in here. And I decide to come over here and I decide I'm going to do a scatter plot of all the data that's in here. And I come over here and I start to plot the points. Now notice I haven't told you anything about what these things mean. I haven't told you that X corresponds to somebody's to their weight, to their height, to their IQ, to their shoe size. I don't know. But I go ahead and I plot all of these points and I get something that looks like this. And even though I don't know anything about the data, I look at this picture and I go, hey, you know something? There's something going on here. There's a whole bunch of points right over here that seem to be very close to each other. And then there are a whole bunch of points right over here that seem to be very close to each other. And then there are a whole bunch of points right over here that seem to be very close to each other. Okay, so I'm going to say close to each other, and I'm going to use another word that we've used before already, similarity. In other words, I don't know what it is I'm measuring in this file here of data, but when I plot them, I am noticing that there are certain similarities that seem to exist. All of the points over here seem to have some relationship to each other. There's something in common with them. So this is what's called unsupervised learning, and this process that I just went through here is what's referred to as clustering. Okay, so a lot of times when people use the term unsupervised learning, that's just a fancy $2 word for saying what we're really doing is clustering. Now, there are a couple of things over here to note about these. It appears that what we've done here is that we have 3 clusters. And the question is what kind of similarity have we used here? Well, the similarity that we've used in this particular example is that we have sort of grouped points that are geographically close to each other. That was, in other words, similarity in this particular example meant geographically close. But there are other ways of measuring similarity. And again, and I'll probably mention this 7 or 8 times in the next couple of talks, that at least when it came to looking at documents, we had 3 measures of similarity. Okay, so number 1 was the Jaccard coefficient. And you may recall that that was looking at the words in document A, and we were intersecting that with the words in document B, and we were looking at the size of that set, and we were dividing that by the words in A union the words in B, and looking at the size of that. And we notice that this is a number that will be between 0 and 1. The closer to 1, the more similar they were. The other thing that we looked at is we looked at the cosine similarity. Okay, and remember the cosine similarity was looking at A dot B over the magnitude of A times the magnitude of B. Okay, and this was actually equal to the cosine of the angle between the 2 documents. Okay, and again, the closer this was to 1, the more similar they were, because remember, if it's 1, that means the cosine of theta is 1, which would mean that theta is 0 degrees. It would mean that these 2 documents basically lie right on top of each other. On the other hand, if this turned out to be 0, okay, did I get that right? Then they're perpendicular to each other. Okay. So that was another, again, both of these are showing that the documents are more similar the closer they are to 1, less similar when they are to 0. And we said the third thing that you could do is you could also look at the Euclidean distance. Okay, and remember, both of these assume that we're using a vector representation for the document. So with these different ways of measuring similarity, we have 3 different ways of clustering the documents, and we will talk more about that shortly. Anyway, that's the end of this talk. I just wanted to introduce the notion of what is called supervised learning with feedback, and unsupervised learning.